Welcome to the Deep Dive, where we take a stack of fascinating sources and extract the core insights just for you. Today we're diving into something genuinely groundbreaking. Solar panels that generate electricity not just from sunlight, but also from rain. Sounds almost too good to be true, right? Let's unpack this.
It really does sound futuristic, but it tackles a huge issue with traditional solar, that frustrating intermittency, especially in places where the weather isn't always sunny. Our sources suggest this dual approach could fundamentally reshape how we think about renewable power.
Absolutely. Anyone who has solar panels, or is even just thinking about them, knows the but. You get these fantastic sunny days, like 60, 80 kilowatt hours from an 18 kilowatt array, say, in Cincinnati. But then on an overcast, rainy day, our sources show that can plummet to nearly zero. We even saw one system, 24 panels, produce as little as 0.134 kilowatt hour on some cloudy winter days. It's this massive energy gap. Is there any way around that reliance on sunshine, or is it just...
Well, that variability is precisely the hurdle, right? It's the big challenge traditional solar has always faced. But what if rain itself could become part of the solution? Researchers, specifically from Suzhou University in China, they pioneered integrating something called triboelectric nanogenerators. TNGs for short, with standard photovoltaic panels.
TNJs.
And what's really fascinating here, what our sources highlight, is they've managed to create this dual function system without reducing the solar efficiency.
Wait, really? Without losing solar power?
Exactly. It's genuinely an all-weather approach to capturing energy.
Okay, so that's the problem and the breakthrough. But how on earth does this actually work? How do raindrops make electricity? It doesn't sound intuitive.
Yeah, it's not like tiny hydroelectric dams or anything. It's actually about friction, something we encounter all the time. It's based on what's called the triboelectric effect. Basically, when a raindrop hits the panel surface, the friction between the water and the surface material creates a tiny electric charge.
Okay. Like static electricity almost.
Sort of, yeah. Each single raindrop impact generates a small electric current. Now, one drop isn't much, but it accumulates across the whole panel as the rain falls, and the initial results are pretty impressive. Studies on these droplet-based tangs, or D-tangs, showed things like 15 microamps short-circuit current, 1800 volts open-circuit voltage, and around 325 microwatts max power during heavy rain.
Microwatts sounds small, though.
Per impact, yes, but here's a really remarkable finding. Under certain heavy rain conditions, these tangs actually generated more power per square meter, I think around 40 milliwatts, than the solar cells themselves could manage in those same dim, rainy conditions.
More than the solar cell.
Yeah, about 40.88 milliwatts for the tang versus 37.03 milliwatts for the solar in one test case. And they've already improved it, moving to interconnected arrays, one design, a kind of bridge array configuration that showed nearly a 5-fold boost in efficiency. So the potential is growing.
So it's not just a tiny top-up. It could actually be significant power, especially when solar's offline. That really changes the energy profile. What does this all mean, then, for places like, say, Cincinnati again? They get about 44 inches of rain a year, but also 178 sunny days. Seems like a prime candidate.
Exactly. It's perfect for climates with that kind of mix. This tech could genuinely flatten out those energy production swings. You'd get a much more consistent, reliable stream of renewable power year-round.
Which means for you, the homeowner, a potentially much better return on investment, right? Your panels are working more often.
Absolutely. It makes the economics potentially more attractive. And think bigger scale, too. Imagine huge solar tang canopies over parking lots. They'd provide consistent energy, shade, and help reduce that urban heat island effect. Lots of potential benefit.
Okay, sounds great, but what are the catches? It can't be perfect yet.
No, definitely not plug and play tomorrow. As we mentioned, the output from individual impacts is still relatively low microwatts to milliwatts. So scaling up that cumulative output is still a key challenge. And cost is a big one. In Cincinnati, a standard solar install might average around $30,000. These new hybrid systems will inevitably cost more initially. That added cost needs to be clearly justified by the extra energy generated, especially in the early days.
Right.
And retrofitting existing panels, our sources suggest that might be tricky. So it's probably more likely we'll see these in new installations first for early adopters.
Okay, so challenges remain. But this deep dive really shows how these rain-powered solar panels represent a major leap. They're tackling head-on the biggest limitation of traditional solar, that dependence on clear skies.
Yeah, and if you connect this to the bigger picture, think about climate change. We're seeing more extreme precipitation events in many areas. Technologies that can actually harness that rainfall for energy could become, well, a really crucial part of building resilient energy systems for the future.
So imagine a future where your home's energy supply truly works, no matter sunshine or rain. Seriously, what new possibilities does that open up for you?